Hi guys. Hi everyone. This is Mr. DeFelice. I'm going to go through your notes for day 2. And we're going to work on interpreting different representations of a function. We're going to use function notation and then evaluate and perform operations of the functions. So let's start off with what we know. Suppose you have this equation. Determine the value of y given x equals 2. You probably remember this from Algebra 1. But in this problem, all I'm doing is substituting in 2 for x into the equation. So everywhere I see an x, I'm going to replace it with a 2. And then you just use your order of operations to solve. 2 squared is 4. 4 times 2 is 8. And then minus 17. So your final answer is negative 5. We're going to apply this knowledge that we have from Algebra 1 into Algebra 2 using function notation. So for problem 1, the following equation represents the same equation above, just written in function notation. This equation is read as f of x equals x squared plus 4x minus 17. So the new change is that we replaced y with f of x. And f of x is how I pronounce this symbol right here. This doesn't mean f times x. This isn't distributing anything. It's the name of this expression over here, or this function. We say it as f of x. So we're going to use the function f of x, and we're going to evaluate f of 2. And it essentially means the same thing. F is the name of your function, and this part right here is what you're inputting into your function. So in this case, I'm going to input 2 into this function and see what comes out. So the way you write this is you say f of 2, and then you do the same thing as we did above. You're just plugging in 2 where all the x's are. So you get the same answer. Notice I'm not solving for f or trying to get f by itself. This is the name of the function. So I'm saying f of 2 equals negative 5. When I put an input of 2 into this function, the output is negative 5. So remember that a function is like a machine in that it receives an input, does something, and in our case, here's what it's doing to the input, and then produces an output. So in this problem, what is the input? In this problem, the input was 2. And you can see that in the question because it's the number inside the parentheses. That's what you're inputting into the function. And the output was negative 5. So we're just taking our knowledge from Algebra 1 and applying it to the functions as we work with them in Algebra 2. The second question, letter C, or the third question I should say, asks, describe the operations done to the input to produce the output. So what's happening to 2 as we plug it into this function? Well, here it's being squared, then multiplied, and then we're adding and subtracting. So we have a couple operations. We are squaring and multiplying and then adding and subtracting. So I'm taking my input of 2 and I'm doing all these operations to it to get my output of negative 5. So what is meant by f of 2? Well, f of 2 is asking, what is your output when your input is 2? So I can rewrite this as f of 2 equals negative 5. My input of 2 gives me an output of negative 5. That's what it's meant by f of 2. It's asking you to tell me what's the output when 2 goes into your function. So when 2 goes into this rule up here, what comes out? Negative 5. Again, I'm not trying to solve for f. This is done. This is my answer here. This is my input and this is my output. It's just like above when we did the y and the x's, but now we're changing it to f of x for our output information. So go to the next page for problem 2, and let's use some of that function notation to evaluate. Yesterday we went through different ways to represent functions. So we had ordered pairs, we had graphs, We had a table down there in letter D. We had equations and mapping diagrams. Those are different ways to represent functions. But now we can evaluate the functions using that function notation. So here's our function for letter A. It lists the coordinates as such, and it's asking you to evaluate. So this is saying f of 7. So when my input is 7, what is my output? So I look at my ordered pairs and I look for the input value. The input value of 7 is here. What's your output value? It's 8. When 7 goes in, 8 comes out, because these are the ones that are paired together. Now be careful, the second question of this letter A is giving you an output value, and it's asking you what number do I input to get 10. So I look at my y values this time, and I find 10. So to get 10 as an output, I have to input 9. And there's my evaluation using ordered pairs. Let's try doing it as a graph as well. Here it tells you the name of the function is f of x. So the function is this graph. And remember, I can tell this is a function. I can apply the vertical line test. As long as if I draw a vertical line through the graph and it's only crossing at one point throughout the entire graph, then it's a function. And that's true because there's never a point where I'm crossing more than once. So every input only has one output. So let's see if we can interpret this in our graph. F of -4. So I'm looking at when my input is -4. Well, input is just another word for your x values. And y is another word for your output values. So if I input -4 into this function, I'm going to go to -4 on the x-axis. 1, 2, 3, 4, negative. And I'm going to look where it's crossing for my output. And that looks like it's at +2. Do the same thing again. When I input 0, where is my function crossing if my input is 0? It's crossing at 0. So my input is 0 and my output is 0. Now I'm going to go to my input of +2 and my output is -2. My input of -5, so I'm going to go to my x value at -5 and my output happens to be 0 again. Remember, that's okay. You can have different inputs having the same output. You just can't have one input having two different outputs. Again, the bottom two questions here, this time they're giving me output values. So I'm going to look at where y is -2 and then look and see if there's anywhere that the graph is crossing at -2. And we already did this one. We said that this was when the input was 2. Here, it's asking when is my output 0. So if I look again, 0 on the y-axis is right here, and I'm crossing at 2 points on this graph. One right there, and one right there. So I actually have two inputs, f of 0 and f of -5 also gives me 0. Try solving C, D, E, F, and G on your own. Mrs. Versailles or I will have an answer key for you, and you can check in with us. Once you're completed with that, you can work on your day 2 follow-up questions. Good luck.